Okay, so today we're going to be looking at parsing text. This is one of the things where VBA really is pretty good, and you'll get the opportunity to parse through text. It's a common thing. We've already learned a lot of the fundamentals through this, right? The string manipulation functions, left, right, mid, in string, replace. So all these functions will be really helpful to us, but it's also getting us ready for interacting with web servers that require a password. So when you have to parse an HTML document, it's just text. And so the tools that we're seeing here are really just looking at text files, but they will be helpful to us in working with data that we pull from web servers as well. So we've got a set of data here to download. It's a zip file, so go ahead and download that folder, get it extracted. And I'm not even sure quite how this extracts. Let me go ahead and extract all. And it looks like it made a folder right next to the zip file just called weather data. All right, let me just go ahead and open up what's this one, the 3? Maybe this is okay. No, I think I want to open a different one. I'm going to do the 2008 X11. All right, so this is the data that we have. In fact, this is data that I got from one of my former students. She was a student at the time, but she came to me saying, hey, my father has to deal with this data every month or something, and he's got to be able to extract the data out of it, and I'm hoping that I can help him with VBA to make his job a little bit easier. And I said, hey, this is a really interesting problem, kind of a current problem that we needed to solve there in class. So I thought it might be a good example for this. So, kind of understand where we are. We got to set the Wayback Machine for like the 1960s. In the 1960s, you weren't born yet, but in the 1960s, if your company had a computer, how many computers did it have? It had one. Yeah, the thought that you might have 2 computers is absurd. Why would you ever need 2 computers? And yet, people, a lot of employees needed data from those computers. And so how would you get the data from that computer? There's only one computer, the whole company. There might be hundreds, even thousands of employees that might need access to that data. How are you going to get it? The dot matrix printer. You've seen the green bar paper? It's this wide paper, white bar, green bar, white bar, and printers that just print, just go crazy. They print, really fast. Yeah, the little tractor feed, you kind of take them off the side and whatever. It was great, great fun. So, and then, so you might get your reports, depending on what you needed the reports for, you might get your reports every week. There's a guy, kind of like the mail delivery guy in the corporation, going on with a cart of printed reports. And he's just delivering the reports to everyone who needs their report for the week to be able to do their thing. And that worked pretty well. It was, to us, it seems crazy to get like a thick printout, a couple inches thick, of your data to work with for the week and showing your sales figures or whatever it is. That's the way that it used to be. Then, now, fast forward to the 1980s, and now we've got, lots of computers. You probably, if you're working with data, you probably have a computer at your office. But you're still getting your green bar reports. And so, what do you think? Were these computers that were designed when we never expected to have more than one computer in the company, are they prepared to share data with other computers? Not at all. And so we got to figure out a way. How are we going to get the data off of this computer onto my computer for me able to do the analysis? Because now, I've got Quattro Pro. You even know what Quattro Pro was? That was the spreadsheet that knocked Lotus Pro or Lotus 123 out of popularity, and then was supplanted by Microsoft Excel. But I've got this data, and it doesn't do me any good to have the data on paper. I've got to get it in here for analysis. So, if we think about the dot matrix printers of the day, they were really simple, right? You plug them into the computer onto that port, and then the software would just send ASCII codes to that port. It would just send 65, and the printer would go A. It would send 66, and it would go B. It would send 13 and it would send the print head back. It would send 10 and it would advance the platen. And so what are we going to do? That's the way the printers of the day work. What are we going to do now to be able to get the data off of that machine? And the answer is, some really bright person thought, you know, if I plug a printer into this port, just sends all these characters and it prints into the paper. Well, instead of having a printer that's going to actually print this onto paper, I'll have a printer that instead writes it to a floppy disk. We plug in a printer, and as far as the main computer is concerned, it's just printing. But that printer, instead of writing those characters one at a time out to the paper, it writes it out to disk. And so we could get we could get all these reports that we used to get on paper. We could now get them as files. And you know, floppy disk. You know, in the 1980s, it was probably an 8-inch floppy. They're like this big. They were huge. And so it became then really common to get data in this kind of format. Now, the thing about this is that this is meant for a human to read, right? It's organized. It's probably 80 columns wide, and it's all, you know, kind of organized nicely here in the visual columns and so forth. It's got headers, so every so often you can see what the data is supposed to be at the top. You don't have to go back to the top of the file. And so it turns out that it is still common today to be able to get data in this format. Those systems that were written in the 1970s, 1980s, it's unbelievable how many of those are still like running things, especially in governments. In fact, I have a colleague at the University of Tulsa. They have a whole program. It's one of the only programs in the nation that teaches people how to be COBOL programmers. The language of these big machines is COBOL. C-O-B-O-L, Common Business Oriented Language or something. And it's like a dying language, meaning the people who know it are dying. But you know, still millions upon millions upon millions of lines of code that are mission critical that companies need to find people to be able to hire. So these, you know, they're turning out these kids who know COBOL from this one program, and they're taking 6-figure jobs, you know, walking out of their bachelor's degree because just as a function of supply and demand. So the point is, there's still a lot of data like this. And so this is a pretty good example for a text file that we're going to need to pull some data out of. Now, my former student's, you know, father, I don't know what he had to do with this data, but we're just going to pull this data in a way that we could process it uniformly. So we're going to take this from being human readable paper into, you know, data, like, you know, columns of data that we could then, you know, build a pivot table on. Could you make a pivot table on this data? Like just import it into Excel, make a pivot table? Not a chance. That's our goal then, is to be able to pull it into Excel. So first thing is, what is this data? Somebody tell me something about this data. You know, something other than it's just characters. You know, say something about it. Go ahead. Okay, so this is having to do with Brazil. Here's Sao Paulo. I'm not sure, you know, why Sao Paulo has the stars by it, but and then these Franca. What's Franca? Anyone know? Is it a city? So, you know, maybe this is some kind of region marker, and this is then, you know, location inside that region. Okay, good. What else? What else can you see about it? Yeah. This looks great. Precipitation in millimeters, and we can see that we've got some kind of summary month data. So here's precipitation millimeters, June of 2008. And so in Franca, there was 12 millimeters, and that was half of normal for that month, apparently. And then we actually kind of have 2 blocks of each. There's this percent of normal block, and then there's this raw data block. And so what we're seeing here is we're seeing from the 4th of November to the 10th of November, 4th through the 10th. These are the actual measurements from each one of these weather stations. So apparently this is each one of these is somewhere where they measure precipitation. I don't know what else they measure there, but they're giving us precipitation numbers from here. Well, that looks great. You folks did a better job of figuring out this data than any other class I've ever had. And apparently I've been doing this since 2008 or thereabouts, because that's when this data was current when I got this data. So. So give yourselves a pat on the back. Excellent. So server mission in Brazil? Argentina. Spend a lot of time out of your mission? No? Yeah. All right. So this is going to be our goal then, is to be able to read through this file and build something that says, all right, at this station, we may bring in the call number, but that call number appears to represent this station. On November 4th, 2008, 0 precipitation. That's going to be one row. Another row, same station, different date, number for that precipitation. That's where we're headed. And of course, we don't want to do it by hand. Right? We want to do it automatically. So let's get down to business. You go ahead and get back into Excel. So I've got a blank workbook. We're starting from scratch today. I always like to start from scratch. There's no magic here. Insert a module. Okay, so our first let's just work on one file at a time. So get one file. The idea is we're going to have lots of files that we have to process through, a pretty common thing. But we've seen how to process, multiple files, how to be able to read sets of files and get the paths to those files. So here, let's just say we're going to get one file, or maybe process one file. And so we will pass it the path of the file that we want to process. So I'll also get myself set up to run this with my Acme sub runner. And we're just going to call process one file. And I think I'm going to save, I think I'm going to save this workbook at the same place where the folder is saved that has the weather data. So not inside where all the weather files are. Uh-oh, I put this in network shortcuts. That is not where I meant to put it. That was weird. I'm going to move this somewhere else and go re-extract it. I'm going to put it in downloads. There we go. I'll put my weather data here. I will extract it here. All right. So now I'm going to save this file at the sister location of that folder. So file, save, and I'm going to go to downloads. Yeah, there's weather data. I'm not going to put it inside of weather data. That's where the individual files are. I'm going to put it right next to weather data. And so we'll make this, let's call it weather, fall of 19, XLSM. All right. So now I can process one file, and now, because I know where those files are relationally to my Excel file, I can just find one of those files by using this workbook. .path, concatenated with, and then applicate .path separator. I could just use a backslash. I'm here on Windows, but remember, path separator is how I can get the right path separator, whether I'm in Windows or Mac or whatever. By the way, did anyone call the gal from the law school to see if you could work out to help her with her issues? No one? Oh, okay. Well, good. I'm glad that at least her time wasn't wasted to come here. Somebody responded to her. This workbook.path application path separator. Oh, and then the name of one of those files. I've got one open here. Just copy the file name from there. WSI 2008 11. So November of 2008. WSI, Weather Something Institute. I don't know what it stands for. Process one file. What am I missing? What am I missing here? Oh, quotes are wrong. All right, so I'm just going to go ahead and put a stop in here, and we'll run this. All right, so I'm here. I should be able to print out the path and make sure that came through right. That looks right. Okay. So far, the only way we've opened files in this class has been to open them into Excel. But what we need to do here is we just need to open that file in such a way that we can just look at the data directly. And fortunately, that's built right into VBA. And so there's a statement called open. So I'm going to come in here and say open, and then I've got some full path to a file that I want to open, a text file that I want to open. And since I've passed that path in here, I'll just say path. Now I got to tell it, how am I going to open it? Am I going to open it for writing data to it, or from reading data from it, or for both? I could open a file and I could kind of go both ways with it, but it has to know what's my intentions. What are my intentions with the file? And this next part comes from the perspective of VBA, not the perspective of the file. So from my program's perspective, I'm going to be bringing data in. So it'll be coming out of the file into my program. So I'm going to open it for input. And then I have to give it some way for me to refer to it. Now, this statement goes, literally, this statement goes back to the 1970s. It's kind of one of the early things in BASIC that's kind of persisted across. Today, if we were writing, in fact, Microsoft has written different ways to access files in VBA, but you have to declare other objects and use those methods and properties. But it would be an object that would have methods and properties that we could manipulate. This is before the thought of making BASIC into an object-oriented language. And the first object-oriented languages were in the 1960s. They didn't really catch on until the 80s. In BASIC, they didn't really come into BASIC until the 90s. So it's kind of this will seem a little strange, a little foreign to you. It's okay, it is. I'm going to give it a number as number 1. So instead of having an object that refers to it, I'm going to number it. Now the whole reason is I might have 3 or 4 files open at once. 3 of them I'm reading data into, 1 of them I'm writing data out to. I've got to be able to somehow keep track of which one I'm talking about. And so that's what that number does. This is number 1. Yeah. Yeah, the question is, can I explain for input again? And the answer is, this is, what am I going to do with this file? Am I going to write data out to it? So output, I could open it for output. And if I open it for output, I start writing to the file, and it replaces the file if it's there already. Yeah, I'm going to read data into my program from the file. Another one is for append. So I could say, open the file, don't write over it, but just push some more data onto the end of it. Or input. These are the main ones that we use working with text files. There's also for random, and there's for binary. You want to work with binary data instead of text data. And then random is like random access, both read and write at the same time. Okay, then I'm going to do some stuff with it, and then I'm going to close it. Close number 1. And I use that number. Anytime I have a file operation, now I got to tell it which file I'm talking about. And so I'm closing a file, I'm closing number 1. Even though it's the only tile I have open, I've got to tell it the number still. Go ahead. Do you have to use the pound? And the answer is sometimes you do and sometimes you don't. Let's take it off up here and see if it even likes it. It might be okay without it. I'm going to leave it in there just because since the 1980s when I started with BASIC, that's what you did. And maybe after we get it going, we'll test it, see if we can pull them out. Okay. Now, oh, you know what? I always forget this part. Now, here's one of the neat things about working with files this way is that, what do you think? Pretty common to have a file that's bigger than I can put into memory. You got like 16 gigabytes of memory. How big is 16 gigabytes? I think we talked about it once. Didn't we talked about how tall a stack of Book of Mormons you could fit into 16 megabytes. And it was tall, I don't remember, but it's a lot of data. Definitely bigger than any computer in the 60s. But now here, remember this, the computers in the 60s, they didn't have very much memory at all. And so the thought that we might read a whole file into memory seems wanton and luxurious. If you could do that, no way. We have to read just a part of it at a time. And so, but now in the world of big data, can we have files that we have to work through that won't fit into memory all at once? Absolutely. And so even though this file is tiny and we could read it into memory and to work with it as a single variable, I'm going to show you this approach for working with huge files. So what I'm going to say is line, well, let's kind of play with it first. One thing I can just say input. I'll need a variable. So let's do this. Oops, cancel. I'm going to back off of this example, so you may want to follow this along. You may not want to. Dim the file as a string. Now, string can only hold 4 gigabytes. So regardless of how much memory you have, a string variable only holds 4 gigabytes of memory, 4 gigabytes of data. So I could say the file equals input. And I'll tell it how many characters I want. 1,000 characters off of file number 1. I don't think I can put the crosshatch there. Maybe I can. Let's see if that works. So I'm going to run this. And then I'm just going to print the file. And this should be the whole file. Oh, I think I hit play and said, did I drag it back up there? Let's try this again. File not found. So it doesn't like this. Let me see if I can get a direct. We've got to first find out where the file is. Dir of path, probably going to bring back a 0-length string. So what's wrong with this? Oh, it's because there's a data folder in there. It's called weather data. Yeah, weather data. So I got to get that in there as well. I wrote this as if it was in the same place. So rather than bring in the path separator, I'm just going to put a backslash here. So let's stop that. Let's run this again. Okay, so now we're actually finding that file. Okay, and I think we've run it. So we should have the file should be here. Yeah, there it is. Now my immediate window only gets 200. It doesn't even seem like 200. Oh, it's because I only read the first 1,000 characters. So that's the first 1,000 characters of that file. Now, fortunately, I can ask how many characters there are in a file. Like I say, read the whole file. And that is, there's a function called LOF, length of file. So tell length of file 1. I wonder if I can put the pound sign there too. Nope. Length of file 1. And then it should give me the whole file. So yeah, now I've got the whole file here. I only get the last 200 lines here because that's all the bigger the immediate window is. So we've got 200 lines to work with. Okay, so this is the approach that would bring in the whole file at once. I'm not going to do that. So I'm just going to comment that out. But that's an important example because a lot of times that's what you want to do. Small file, just read it into memory, and then I've got the whole thing there to work with. Now, if I want to find one line at a time, this is a common use case. So I can just say, just give me the first line. And then I'll say, give me the next line. Give me the next line. So let me create another variable here. And this is the one you will want to follow along with me if you're trying to follow along. Dim one line as a string. And now I'll say line input. I hope this is right. Might have to look up the syntax if I don't have it right here. I think I then tell it the file number I want, and I give it a variable number to put it into. Might have the order wrong. Let's find out. One line. So I'll come back here to where I open the file, line input. All right, I got to look up the syntax real quick. A line input statement. File number, variable name. That looks great. What am I missing? Line input, oh, maybe the number. Line input number 1. There we go. So at least there we know we do have to put the pound sign on. So I'll run this again. In fact, I'm going to put my stop before I close. Back when I was reading the whole file in, it kind of makes sense. Read the file, close the file. But now I've only got one line. I don't want to close the file right away because I got more lines that I want to read. So I'll run that to my stop. And now let's look at one line. This should have read the first line of the file into this variable one line. So let's go back and look at my text file. And yeah, that looks like the first line. That looks great. I've got one line at a time. Now, all I have to do to get the next line is just call line input again. And that should give me the next line. And it turns out the next line is the first one that I'm really interested in, because this has for me the month and the year. All of this data is from 1 month and 1 year. In fact, if I have it, I'm seeing a whole, what am I seeing, 10 days or a week? I'm seeing a week of data. But what happens if the week spans a month? What if I got 3 days in 1 week and then 4 days in the next week? Let me show you, just so you can believe me here. This is weather data. So here's one that is just November 1st, 2nd, and 3rd. So when only part of the week is in the month, we say only put the part of the week that's in this month. So I get fewer numbers. So it's going to cause a little bit of interest for us, because whatever we write has to be able to figure out how many days there are, because there's not always a week. There might be only 1 day there. Okay, but the point is that November 8th, that's going to be the year and the month that I need for all of my dates. So I might as well just pick those up right here on the second line. So I'll declare myself a variable called YRMO, year month. YRMO. That reminds me of Southern California. Hey, Marietta guy, Chase. You know YRMO, don't you? Yeah. That's in California, or is it in Nevada? It's right there on the way. I think it's in California. It's California, because it's this side of the inspection station. We were raised in the same part of the same state. So we have common bond now. Okay. What was I talking about? Oh, YRMO. So as a string. That will reset your project. That's okay. Okay, so now, so what I have sitting in memory inside my one-line variable is I've got this collection of characters. I've got that string. How am I going to get the year and the month? Any thoughts? Go ahead. That's exactly what we're going to do. We're going to parse this string, but I got to have something that will work not just for June to November. That what if they put January in here? I don't think I can rely on that always being the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. I can't rely on that N always being the 19th character. So what do you think? How am I going to get it? Maybe look for the first dash. I like it. Look for the first dash. I like that a lot. So let me go ahead and I'll get another variable here. I'll call it position, or just short POS. It's short for position. As an integer. Probably integer will be okay, because I'm not dealing with large amounts. Maybe would I get a line that's longer than 255 characters? Maybe not. I might be able to get by with byte. But I feel a little bit more comfortable with integer here. And then I will now, if I look at this, I've read the first line, I read the second line, and so now the second line is in one line. What happened to the first line? Poof, yeah, no longer have access to it. I read it, I didn't need it, so I read something else and put it right over the top. Can I go back? No, this is, the way I've opened this file, it is a forward read only. Okay, so now I've got the second line, and so now I'm ready to say position equals in string, starting at the first character, looking for the hyphen, whoops, looking at one line, looking for the hyphen. So, oh yeah, in string, the question is what's the one, and that says which character should you start looking for? So, yeah, I don't really see a really good example here, but you might say, I don't care about the first 10 characters. So start looking at the 11th character. All right, let me run this. And now position should be something around 19. Well, it's probably finding the hyphen, so it's probably 18 or somewhere there close. Yeah, so it's 18. So now my year month is going to be equal to mid of my one line, starting at my position and taking 1, 2, 3, 4, 5, 6, 7. Seven characters? Let's see what that brings us. I think so. I think these are going to be three character month abbreviations here. So we'll just have a 2-year digit, a 2-digit year, a 3-character month. And I'm going to go ahead and bring on this equal sign because ultimately when I get down there and I look at like the 10th, I'm going to just want to read the day and take the 10, attach that to my month year, and I've got the full date that I'm ready to write out to my cell. So pretty good. So the first thing done, I now have figured out the year and the month. I don't have to look at this file anymore for year and month. I know the year and the month. That's great. All right. Now, what am I going to do? Oh, boy. I got all this data that I don't care about. All this percent of normal, I don't care about. I'm after the raw data. So I got to come up with something that lets me look through this file, reading one line at a time, and be able to figure out when I've got to the data that I need. Any thoughts? Yeah. Good question. Is it always the same number of lines? And when I look here, let's go look at this one. So I don't even know how to say this, Minas Gerius, however that is. I think this region has this number of stations. And the truth be told, I have no idea the difference between the $sign here and the asterisk here. Maybe it's some kind of categorization, but they've got, what is it? Looks like 20 or so. And then Sao Paulo looks like it's got 6.
From where we have a date to where we have our first line of raw data?
Well, no. So the question is, how about from where we find the date to when we find the first line of raw data? And the answer is no, because we've got to blow through this percent of normal data, and that's going to be different for each one. So number of lines, I don't think it's going to do it. I got to find something about the line. I got to look for a particular kind of line. When I get that line, I can look at it and go, aha! So $sign might be good. Trouble with $sign is I'll see the $sign here, and I'm not there. I've got a bunch of $signs to go through. This $sign looks pretty good. But I do know that some of these start with an asterisk. I'm not sure that we wouldn't find one that has an asterisk on the first line. So maybe these 3 asterisks, that might be pretty good, yeah? Oh, so what you're saying here is you're saying when you get to the line that's got a range, this place to this place, you're getting close, right? This date to this date. Yeah, I think that would do it for us. The trouble is, that's kind of tough for us to figure out. Now, there's a thing called regular expression that we could write to be able to see that. And VBA supports regular expressions, but they're not native. And they have their own set of complexity. So if we were already good with regular expressions, that might be a really good way to do it. But because we're not, let's see if we can find something that's a little simpler. Okay, so you just said we have already, oh, and maybe that's what you're saying. We actually have already written out year month. And so we could just look at every line until we find year month in there twice. Oh, that would be pretty good because we won't see it here. We won't see it here. We won't see it here. So each time we look at a line, we can ask, in string of that, find out where it found it. And if it did find it, look again after that position and see if it finds it again. That would work. That's way more work than I want to do. There's a way easier way to do it. So let's kind of, but this is the process. This is the process where you say, How am I gonna get connected into this data that was never intended to be used the way I'm trying to use it? And if it was intended this way, there'd be more structure to it that I could use. But there's not. Okay, so was another comment over here? No? I think it may be. So yeah, that might be pretty good. I could look for the name of the month. Now I like that better than finding two of these because this is just one. Does this line have November in it? The only trouble is I would have to have some kind of table that converts that into the full month. Wouldn't be too bad, but if we notice here, norm, a line that ends in norm, up here it's compressed a little more, it's percent of normal. But here it's just norm. And so once I get to the line that ends in norm, I am on the line that has my day data. So I think with a little work, you might have found something. Then there might be other things that are as easy as that, but that's really easy. Is the last four characters of this line norm? So here's what I'm going to do. I'm going to come here, and after I've got my year and my month, I'm just going to say a little comment here. Find the raw data, and I'll just put myself into a loop. Do until the rightmost of one line, 4 characters, equals norm. Anyone named Norm here in the class today? No? Oh, you took accounting from Norm? That was a while ago. Oh, no, he's probably still on the videos, yeah. And loop. Now, what do I want to do inside the, what do I want to do inside the loop? Oh, yeah, good idea. Let's do events in there. Not what I was thinking, but right, do events, keep me from putting myself accidentally into a boy. And if I just ran that, it would be an endless loop, right? Because I haven't done anything to change one line. So what do I do to change one line? Just another line input. Because remember, line input just reads the next line from the file, puts it into the variable. So I'll get the next, I'm going to say, you know, is the last 4 characters norm? Nope, read another line. Is the last 4 characters norm? Nope, read another line. We'll just keep reading until I got a line where the last 4 characters are norm. So the question is, line input automatically moves to the next line, and the answer is yes. So when you call line input, it gives you a line, and then a subsequent call will give you the next line. Yeah, you don't have to tell it to advance. It advances automatically. And the whole idea here is that this was intended, it was designed to do just what we're doing with it. To read sequentially through a file, not one character at a time, which we could do, right? Because here we could look at just, instead of the length of the file, we could just put 1 character. We can go 1 character at a time. Ugh. Sometimes that's what you want to do. Not very often, but this looks pretty good. So am I still running it? Yeah, I'm just going to come right back up here to my do loop. And now it should have that line. Let me go ahead and look at one line again. And hopefully, yeah, there it is. I've got, and this is what I'm really after here. I'm after those days. I'm going to need this set of data. Okay. We doing okay? So far, so good? I'm going to do one more thing here, because this one is going to be scrolling me through. Now, I know that ultimately, once I get this down for one block of data, I'm just going to want to repeat it over and over and over again. And it might not be clear, especially that this is the place that it's going to happen. The prior experience tells me that when I get to the very last one and I come back to the top and say, keep looking for norm, what's going to happen? And it won't find the same one over and over again. It will never find it. It'll just say, keep on reading until you look for norm. Ultimately, it'll try to read past the end of the file. It'll give me an error. So here, let me just say, if EOF, end of file 1, then stop. We'll decide what to do later if we make it that far in the example today. But end of file will be equal to true if I have tried to read past the last line. So similar to when we're working with dir, that you could get the different files in the directory, and then once you read it one time past the end of the file list, you got a blank line, that's okay, but reading the next one is going to give you an error. The similar thing here. You read each line, you read the last line, it doesn't know it's the last line. Then you read it again and it goes, end of file is true, and then if you read it again, error. So as soon as the end of file is true, I'm just going to put a stop here so we can see that it's happening. Okay, so we've got norm. Now we've got to get this data. We need this set of days. And unfortunately, there's not always going to be 7. So we got to get this block of data and somehow save it somewhere temporarily to kind of use it to build, because we've now got the year and the month, we've now got a set of days, and we're getting close to actually getting the data that we have to work with. So any thoughts? Yeah. Ah, I like it. The thought is, let's just make an array. So let's just kind of pull all the data from right in here, split it into an array, and then the size of that array will tell us how many pieces of data we've got to pull for this sheet. Nice. Okay, so let me just think of where this is. There's the first character, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So if I start the 20th character and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and take 40 characters, it'll go somewhere into here. I remember counting out 40 last semester. So that would be, that would bring that in. Now, the problem is going to be that I've got lots of extra spaces in here. But let's see how we might be able to deal with that. So let me go ahead and dim days, D-A-Y-S, as maybe the first time I've done it, a variant, maybe the second time. And that's because I'm going to split this data into an array. And variant is one of the types that let me kind of hook on to a dynamically created array. So let's go ahead and now get the days. I'm going to say days equals the mid of one line, starting at the 20th character, taking 40 characters. So the question is, could we put a trim around that to get rid of the leading and trailing spaces? It would, but it wouldn't do anything with the spaces in the middle. In past years, we've written a function to kind of strip those out, but I think there's a function in Excel that will do it for us. The question is, can we use replace? And the answer is yeah, we could replace all the spaces, and then I wouldn't know how to split it. I need the spaces in there to be able to let me split. I think we're going to be able to get there. I've got in mind to try something we never tried before, so we'll give it a shot. So let's go ahead and I'm just going to go ahead and look at days. I've run that line. Yeah, I've got a bunch of spaces here, but it looks like I've got the data. That looks pretty good. Might want to take more than 40 characters, but I think 40 characters will be okay. Okay, so now days equals worksheet function dot trim. So this is going to use the trim function from inside of Excel, and that behaves differently than the VBA trim function. That's why I can get to it. If it was the same as the VBA trim function, I wouldn't even be able to get to it this way. It wouldn't be exposed. I think this one will get rid of all leading and trailing spaces, and it will collapse sequential internal spaces down to a single space, which will be perfect for our needs. So let's take a look at it now. Yeah, oh, that's beautiful. No leading or trailing spaces, and all those multiple spaces in, yeah, all those multiple spaces inside have been collapsed down to a single space. So that's just what I have never used the trim function in an Excel worksheet, but that's what it does. And it's really handy for us here. So now I'm ready to say split, days equals split days on the space. And in fact, if I don't tell it what to split on, it will assume I mean the space. That's the default character. So now when I run that one, I should have an array. So I can't say show me days anymore because I can't print an array, but I can show days sub 0. And there's the first one. Days sub 6 should be the 10. Yeah, the magical thing here is that I treated days like a string here, behaved just like a string. But now when this thing returns an array, I can bind that right onto days because that's what variant does. That is the thing that variant excels at. I've got some part of data that I want to treat one way at one point and another way at another point. Okay, great. So I've got my days. I'm feeling pretty good about it. Whew. Anything else that I need? So I've got my month, my year, my days. Why don't we go ahead next and get our, do we call this a region? I'm not even sure what that is. Let's call it the region. So this looks pretty good, right? I should just be able to loop through till I find the next place I find 3 stars. From here should be pretty good. So I'm just going to go ahead and copy this line that we have up here. Call it find the region. And, might even be able to look till the last 3 characters or till the last 4 characters are space star, star, star. If I was writing it from scratch, I might look until the first 3 characters, trim it and look for the first 3 characters, but I already had the right and the 4 there. That looks like a great way to do it. And maybe, yeah, if we hit the end of the file, it might be a good thing to stop. I don't think we'll ever hit the end of the file in this one, but I don't have a problem with leaving it in there. So at this point, I should be able to get rid of all the stars and then trim and have just what I'm after. So let's just do that in one step. I'm going to go ahead and declare a region as a string. Now up here, we did this in 3 steps. We could have done it on 1 line. This one's 2 steps, and I'll do it on 1 line, even though it'll make it a little bit harder to read, but just so you can see that that's a possibility. So region equals, and I want to get rid of all the stars. So I will say replace, looking at 1 line, looking for the asterisk, and replacing it with a 0-length string. So now this expression here will be that line without the stars. I just want to now operate the trim on that, so I'll bring my trim statement and just wrap it around the results of that function. This isn't too bad. I'm nesting functions 2 levels here. Would it be a little more readable if I did it in 2 lines? Region equals this, and then trim the region. Region equals the trim. Yeah, it'd be a little more readable. I don't think, but in practice, I would probably do this. I don't think I would go 3 levels unless I was sure no one else would ever have to look at it, because I'd be embarrassed by that code. But that should give me a region now. Oh no, I didn't run the loop yet. So let me run this loop here. Now let's look at my region. Oh, I got the region. Oh, we are moving right along. So now I'm ready to start pulling this data. And I think I'm comfortable to say if I'm on the region, I just want to skip the next 2 lines. So let me just go ahead and read 2 more lines. All right, now I need some kind of do loop to process through this block. So how could I tell? So at this point, let's see, I was on this one, I read this one, and now I read this one. So I already have this line. And whatever I'm about to do here, I want to do Well, let's do it on this one and then we'll figure out how to loop it. So what do we want to do here? Yep. Ah, so what you're saying is this now looks like it's going to be fixed width. Right, I can just pull, I don't need this first character, but I can pull my station, just that set right there and trim it. I can pull my call, this set. Now this one, I don't know where they're going to be, because if I've got 3, they'll be in different places than if I have all 7. So the question is, if we could say, see if there is a space. Yeah, the question is, couldn't we just look at this and say, oh, we got spaces? Then I have a hard time telling the difference between these. But I think we can pull the same magic that we did here and just pull these into an array. It'll be the same size. But let's go ahead and pull in our station and our call. And then we'll pull that data in. And then all of these, this is, yeah, the total across the week. I could calculate that again. And percent of normal, I'm not worried about. So I don't worry about this data here at all. So I'm going to need 3 more things. I'm going to need a station, a call, and maybe just one called data. Let me declare those variables. Call is a reserved word. Call no. And let me dim data as a variant. We'll treat that one just the same way we did the days. Okay, so my station, let's pull the station as mid 2 through, oh, here I'm in Notepad. Let me just go ahead and put this in here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Just so I don't have to count as much. And then this is going to be 10. Not caps lock. That should be 20, 30, 40, 50, 60, 70. Yeah. I've actually never counted this before, but it is 80 columns wide, which is a standard number of columns for a 8.5 wide paper. That's what that is. So that's 80. Okay, so it looks like I want this one to go from 2 to 13 is where I'm going to pull that from. So that's my station. Equals the mid of one line, starting at 2. Oh. And then taking the next 13 characters, not the next 13 characters, but ending at the 13th character. So the next, is it 12 or 11? 12. I think 12 is right. But I do have the luxury of there being a space there always, so I just have to get close. Then this one is going to start at 14 and take 1, 2, 3, 4, 5. What was that one called? That's my station. This is my call number. Equals the mid of one line, starting at the 14th and taking 5. Then I'm going to copy my whole block for get the days. I'll bring this one down and just call it get the data. Change everywhere it says days to data. I don't think I have to think about it. I mean, it is, I'm on the same line. They're in the same order. I think I can pull that in the same way. So let's see. I'm not quite sure where I am. So I'm going to stop this and just run the code again. So let me take a look at station. Station call number looks great. Let me look at my data sub 0. It happens to be 0. Let's find one that's a little more interesting. 0, 1, 2, 3, 4. Number 4 should be a 9. I got it right. Yeah, looks like I got my data as well. I think that's it. I think I'm ready to start writing data out to my sheet. I'm just going to go ahead and write it to whatever the default sheet is. So I will need to figure out which row to write to. So let me go ahead and declare row as a long integer. Let's go ahead and figure out what the row should be. Row equals, and I'm just going to find the first blank row on looking up from the bottom. So row equals current sheet cells. Whoops. Cells rows dot count, how many rows there are, column 1 dot end XL up dot row plus 1. So it'll find bump up until it finds data or the top of the sheet, ask what the row is, and then add 1 to it. So that should give us the first blank line from the bottom, except when there's no data at all, it'll give us the second blank line. That's okay. Now I think I'm ready to write it out. Cells sub R, comma 1. You know, just in fact, to make my life a little bit easier, I'm going to do this. I know I've got to write a bunch of things out. No, there's not that many. I'll just hard code the numbers. Dot value is equal to, and I guess I want what do I want first? Maybe the region. And then in column 2, I want the station. And then in column 3, I want the call number. Whoops, this is row, thank you. So a station, then I want the date. So this is going to be, now I'm going to need and see, I'm going to have to loop through my array that has the date. So let's come back for the date for a minute. I'm going to put the year month, the YRMO. And then I'm also going to need to actually pull in the data itself, 3, 4, 5. All right, so I need another variable. Maybe I'll just declare this variable right here. We just dim x as an integer. For x equals, I just got to go over the lower boundary to the upper boundary of my days. So 0 will be the lower boundary always to the upper boundary of days. Next, I'll tab this in. So now I want my year month, but before I put the year month, I'm going to want my days sub x concatenated with the year month, and then I want data sub x. So days is my array that I read in the actual days, the 4th, the 5th, the 6th, through the 10th. Yes, this is reading the days array at the xth position. And then the same thing, I've got an analogous array here for my data. Okay, so I don't have row yet, but I do have data. So I'm gonna come back up here to where row gets set, and I'll run this. And that should have it should have written 7 rows in. They should all be the same except for the day and the data. Let's take a look. Oh, I didn't increment rows, so I wrote them all on top of each other. So thank you very much. Inside this loop, I'm going to increment row. Stop my code and run it again. And now it will have left that one that was there. I haven't done anything to clear the data off. That's okay. But now I've got 5th or 4th through the 10th, and there's the data, all zeros except for the 8th and the 10th. We got a 9 and an 8. Successfully done the first block. Seems like we've been at it for an hour. And we've just got the first block. But now that we've got the first block, we're almost done. So what do I have to do next? So where am I? I've now processed to right here. Oh no, I don't have the first block. I have the first row. I got to keep doing that little part as long as I've got data in this block. So how could I tell when this block, when I'm done with this block? Right, I'm going to read in this row, and if it looks a certain way, I'm going to process the data. If it looks somehow differently, I got to know, oh, I'm done. How can I tell the difference? Okay, the comment is if the very first character is a space, and the answer is no, there's no space on this line. Oh, well, the trouble is if we look until we hit this, then we've got this line that we've got to deal with. But this line's really different. What is this line? Yeah, it's empty. There's nothing on that line. And so I'll just loop until I find until one line's empty. So I'm going to wrap right around this right here, another loop. Do until until one line is equal to a zero-length string. And I better be reading one line in here. So maybe at the end of this, we'll do another read to get one line in, another line input. Thank you. So now we'll get the first, we'll write out that first line. Oh, no, we've got to put the start of this loop a lot higher because we've got to read the station, we've got to read the call number. So we've already got a one line to read right here. Now I think I want to put it right here. So here's where I want to start. So all the way up there. So right here's where I'm getting my station, getting the call number, reading off the data, splitting it, writing it out to several different lines. And that should be good. Truth is, I don't need to read row each time I do this. I just need to read row probably when I start the program, but at least let me bring this, well, I'll leave it there. Probably should be done at the very top. I just need to find out where I'm writing the data in this file, and then each time I write out, I'll increment, and I should be in good shape. It won't hurt to do it here, just take a little longer. And by a little longer, I mean milliseconds longer. That looks pretty good. I'm going to stop this and run it again to my stop. You know, I'm going to put a do events. I've got a do loop here, so I'm going to put a do events. Tell right back here to one line. Yeah, I like it. We run it. Application to find error. It doesn't, somehow I got stations with a bunch of equal signs. What did I miss here? Let's see what one line is. I got to all equals. Must have got here, which makes me think that really isn't a zero-length string. So well, I don't think there's a space there, but the length of it should be different. So let me also print off the length of these lines. Fortunately, I'm having that, I get to that error. Well, by the way, why is that causing an error? When I try to write this in. What's wrong with putting a bunch of equal signs? Come on, you Excel geniuses. Yeah, I think it's a function. Oh, equals. That doesn't make any sense. Yeah, that's why I'm sure that's why it's failing. Okay, so let me do a debug.print right before I start writing of the length of one line. And I'll clear this and run this again. Yeah, so I'm kind of surprised. Do until one line is blank. It's 0 characters long. Or 0, I've got a couple that are 0 characters long. 78, 0, 52, 0. Does that make sense? Yeah, there's a 0 line, there's a 0 line. So I'll just use that to let me out of the loop. So do until the length of one line is equal to 0. Stop this, run it again, and see what we get. Still no good. 0, 52, 0. Do I have one line spelled wrong here? The length? Oh, do until the length of one line is less than 10. That should do it. Let me just ask. Oh no, length of one line right now is really long because it's got the equal sign in. Oh, here we go. It's because that's what's controlling this loop. So let me get rid of this. And the problem is the next is happening right in here. Is that right? Next, no, that shouldn't be it. This loop should be setting to the top. That should write it out. I think I want you to step through this. Anyone see why it's not working? Oh, it probably is. Yeah, this, let's see. No, I think this is right because what we're doing is we're reading a line. This needs to be outside the for next loop. That's probably exactly what it was. I don't think so. I don't think I put it in. I left that one out. Yeah, I think that's exactly what it was. Because you're right. We've got all our data set there. Don't need to read anything. We're just putting it out. Excellent. There we go. So now we've stopped without error. I'm going to go ahead and come back to my worksheet, clear off all this data, run it again, and just make sure it looks like what we want. We get 7 for each one, and we're ending up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 7 times 15 sounds like 112 to me. I don't know, somewhere in there. It's about the right order of magnitude. Okay, we are so close to being able to process this whole file. We just have to figure out kind of where we go from here. So from here, how do we get to the next place? Well, we need to get from here. See, before we came, we read this, and then we looped until we hit norm. So I think we just got to loop until we hit norm again. From here, we just loop till we find norm, and we've got the next block to start with. So I'm going to put another loop here. And right before we're looking for norm, I'm going to put a do. I'll tab all that in. Yeah. So we got right to here. And this loop has a loop until one line is less than 10. I probably can set that to 0 now, until it's equal to 0 or until it's a 0-length string. But until I bump into that short line, that lets us out of this loop. So at this point, we have finished getting one data block. So what I want to do now is I want to eat through the file until I find one that ends in norm. That's be my next data block. Well, I've already got a loop that does that. And once it gets there, I want to just keep doing this again. So this loop now will send us back up to its due, which is right before we look for norm. Yeah, that's why we have this right here. Is because when we come back up here, we're going to start looking for norm, and if we found all the norms, it's going to go right past the end of the file. So what do we want to do here? If we hit this, what does it mean? Probably we could exit do. Well, if we exit do, it's going to be talking about this one. That's kind of a problem. If I've got two nested do's and I want to exit out the second one, exit sub will do it for me. Coincidentally, I'm totally done at this point, so exit sub will work. Otherwise, it gets a little bit ugly. I think that's it. Finished with 2 minutes to spare. Let's start off by clearing the data. So we don't want to clear it here because it's one file. Maybe I'll clear it right up here. Yeah, the question is there's no condition on our do loop to get out. That's right. So we have a do and we have a loop at the bottom. Neither one has an exit condition on it. And the reason is because it only looks at those exit conditions when it actually is at that location of the code. It comes back up and it says, can I tell by looking here? And the answer is we can't look there and know. Because what we need to do is sense for when we read past the end of the file, and that will happen here. Okay, so now I'm clearing all the data from the cells, processing that one file, and that should be it. I got a bunch from Minas Gerais, and we go to the next one, Sao Paulo, East Coast States, Colombia, Bahia. Got a couple things that are problematic here. If I'm trying to plot this, I've got trace. There was some precipitation, but not even a millimeter. And then I've got dash. I don't know what that means. But that would be something else we probably want to have to deal with in the data. So that's a kind of a pretty complete example of parsing that file. Of course, we've got 3 files to work with, so we could write a loop and just pass each 3 files in there, and we'd be in good shape. Questions? All right, we start working with Internet Explorer next time we get together. And then remember, a week from today, there will be just open lab. So no attendance taken, attendance optional. Thanks for coming, class dismissed.